Hello! Today I would like to show you how to measure the current in an automotive circuit through the fuse using only a multimeter and this chart here that tells you the current through a fuse dependent on the voltage measured across the fuse itself. So inside an automotive fuse there is the fuse wire, which basically acts as a little teeny tiny resistor. So you can stick your voltage probes into the two terminals and measure a voltage difference across the two terminals, which is just displayed on your meter as a voltage. You then take the voltage and you go and look up the chart for whatever kind of fuse it is. In this case it will be a standard fuse and a green one, which is 30 amps. So you take your millivolt reading down one side and it should tell you the milliamp reading of the circuit. Please bear in mind this is an approximation. It is close. It is pretty close. Right, I'm going to set up in this vise here with a load and I'll show you it doing it. Okay, the first thing you do, make sure you've got your leads in the correct terminals. Black one in common, red one in volts or whatever. Just make sure it's not in your amps things or you're about to blow the fuse that you're going to test. Black common, negative, red, voltage in there. Then set your voltmeter to voltage DC. If your voltage meter is not auto ranging like this one, then set it to its lowest, well probably not its lowest, set it to its millivoltage. You might have micro voltage, but you want millivolts. So we're going to read in millivolts. Now we'll turn on the power supply and hopefully not be blinded by the light bulb that I am using as a load. That is basically my load. So on the power supply over here, showing 12 volts and 2.8 amps. And I checked it with the meter and 2.8 amps is pretty close. So let me put that back there. So imagine this fuse here. This is inside the fuse box of a car. Now we're going to try and measure this without melting the leads on the hot bulb. Oh, it does help if you don't touch the benches, the light bulb onto the bench. Hold on, slide forward a bit. Everybody, there we go, don't ground out. Ideal. Right, we are going to test across this fuse with the probes and try to stab them into the fuse properly. So that gives us a voltage of 3.8 millivolts. That's 3.8 millivolts. Polarity, it doesn't matter. Whichever way you test it, you should still get 3.8 millivolts if you've stabbed it in properly. Which I appear to almost be doing. Go back up to 3.8. There enough, 3.7. 3.8 millivolts. Now, you take your list, and what are we on? A green standard. So this sheet has got all sorts of, so there's like a J cartridge fuse, maxi fuse, mini fuse, and the standard fuse, which we are testing just now. Standard fuse, green, 30 amp, and what did I say, 3.8 millivolts. So we come down to 3.8 millivolts, and then we'll go across 3.8 into the green one, which is this one at 2, sorry, this shows 2 amps, and I said 2.7 amps. So like I say, it's close, but it's not quite super accurate. But that also depends if your meter, of course, is super accurate or not, which this is a GP meter. I imagine if you're using a Fluke or something, you might get a different voltage reading, and it might be more accurate. But this setup gets you in a ballpark. So what this is going to be doing, or what you're going to be using this for, is chasing current leaks. If you've got a circuit in a car that's flat in the battery, you either go around and unplug all the fuses to see if it goes away, or you go around and you test them all and see what kind of voltage reading you're getting. So like if you're getting one that matches your load. So for this it's a light bulb. Let me show you that. It is an automotive light bulb. It's 40 or 50 watts or something like that. So it should be drawing, you know, 2 to 3 amps. If it was drawing 5 amps or something, you know, then you've got a problem with the circuit, and it's a good place to start. But hopefully that makes some sense. So voltmeter, millivolts, cross the fuse, take the reading of millivolts, look on the chart, and all these numbers over here are in milliamps, so that's, you know, 1000 milliamps is 1 amp. So that number there, no number thumb, that would be 1.8 amps. And conversely at the other end, or, you know, there's 400 milliamps, that would be 0.4 amps. I will put a link to this sheet. I don't know where it came from originally, but I was watching the channel Watch Wes work, and he showed me, or us, he showed the world how to do this test. So I'll put a link to his channel, and I'll put a link to where you can download these sheets from, and hopefully that may help you in a bit of diagnosing and hunting down leaky voltages. Thanks for watching.